Work and Energy. Part 4. Law of Conservation of Energy. In the previous video, we learned about potential energy. In this video, we will learn about the law of conservation of energy. Earlier, we studied that energy can be transformed from one form to another, like the energy transformation in water cycle and in photosynthesis, or the examples of bow and arrow and a running car, which involves human activities to transform energy from one form to another. But do you know what happens to the total energy of the system before and after the transformation of energy? The total energy always remains the same, even when the energy is transformed from one form to another. This is known as the law of conservation of energy. The law of conservation of energy states that energy can neither be created nor destroyed. It can only be changed from one form to another. Law of conservation of energy is applicable in all situations and in all kinds of energy conversions. Now, let us perform a simple activity to understand the law of conservation of energy. Suppose a ball of mass m undergoes free fall from a height h. At the start of the fall, the potential energy of the ball is equal to mgh and the kinetic energy is equal to 0. Can you answer why the kinetic energy is 0 at the beginning? It is because the ball has no velocity in the beginning. Thus, the total energy of the ball is mgh. As the ball begins to fall, the potential energy is converted into kinetic energy. If the velocity of the ball at a given instance is v, then its kinetic energy is 1/2 mv square. When the ball continues to fall, the potential energy keeps on decreasing and the kinetic energy keeps on increasing. The summation of potential energy and kinetic energy of an object always remains constant at all points. Potential energy plus kinetic energy is equal to constant. mgh plus 1/2 mv square is equal to constant. The potential energy and kinetic energy of an object together forms the mechanical energy of the object. While the free falling of the ball, the amount of decrease in potential energy is the amount of increase in kinetic energy. Thus, there is a continuous transformation of gravitational potential energy to kinetic energy. Now, let us see if the total energy of an object always remains constant or not. Let us find out the kinetic energy, potential energy, and total mechanical energy of an object at two different heights. Suppose an object of mass 10 kilograms is dropped from a height of 5 meters. Take acceleration due to gravity as 10 meters per second square. Let's calculate the potential energy, kinetic energy, and total mechanical energy of the object when the height h is equal to 5 meters. Potential energy of the object, EP is equal to mgh, which is equal to 10 multiplied by 10 multiplied by 5, which is equal to 500 joule. Kinetic energy of the object, EK is equal to 1/2 mv square, which is equal to 1/2 multiplied by 10 multiplied by 0, which is equal to 0 joule. As studied earlier, mechanical energy is equal to EP plus EK, which is equal to 500 plus 0, which is equal to 500 joule. Now, let us calculate the potential energy, kinetic energy and total mechanical energy of the object when the object reaches the ground. And so, the height h is equal to 0 meter. Potential energy of the object EP is equal to mgh, which is equal to 10 multiplied by 10 multiplied by 0, which is equal to 0 joule. Kinetic energy of the object Ek is equal to 1 upon 2 mv square. We know v square minus u square is equal to 2as. Here u is equal to 0. Therefore, v square is equal to 2as, which is equal to 2 multiplied by 10 multiplied by 5, which is equal to 100 meter square per second square. Substituting the value of v in Ek is equal to 1 upon 2 mv square. We get Ek is equal to 1 upon 2 multiplied by 10 multiplied by 100, which is equal to 500 joule. Mechanical energy is equal to 0 plus 500, which is equal to 500 joule. Now, on comparing the total energy of the object at both the heights, we will notice that the total energy remains the same. It shows that the sum of kinetic energy and potential energy is the same at the initial and final positions. Can you calculate the sum at other heights and fill up this table? Then we can see if the total mechanical energy remains constant throughout. In this video, we learned about the law of conservation of energy. In the next video, we will learn about power.